We are at question 54 in our Unit 9 circles review. Question number 54. In the diagram below, ray AC and ray AB are tangent to circle D, and segment CD is a radius. What is the length of segment AB? Well, the first thing I can see is that segment AB has nothing to do with this right triangle, but I know my rules of tangents to the same circle. If they intersect outside the circle, then I know that AC is going to be equal to the length of AB. So if I can find the length of AC, I can find the length of AB. And AC is part of a right triangle. So I can use Pythagorean theorem. So if I look at this diagram, I know this is also 17 meters because that's a radius. If this is my right angle, then this is my hypotenuse because the hypotenuse does not touch the right angle. So let's use Pythagorean theorem. A squared plus b squared equals c squared. I will go ahead and treat side CD as my A value, 17 squared. My B value is side CA, it's the one I don't know. And my C value is going to be 17 plus 19, which is 36 squared. Alright, so I can square the 17 squared, or I can square the 36 squared. You know what? We found a little trick that we used for our planets. We don't have to actually square those numbers. We can go ahead and just do the whole thing in our calculator. We can take 36 squared and we can subtract 17 squared. So I'm going to take 36 squared, I'm going to subtract 17 squared from it, and I'm going to end up with 1007. So I just found in one quick step, class, b squared is equal to 1007. And that means b is equal to the square root of 1007. And that is going to be, let's find out. The square root of, square root of 1007 is equal to 31.73, or we can round that to 31.7. So approximately 31.7 meters. And that means I can write as my final answer AB is equal to 31.7 meters. Alright, question number 55. What is the measure of arc BC? The measure of arc BC. Alright, so I'm looking for this arc right here. I'll just put an X there for a moment. I'll actually just put a dot there to just represent that we're looking for this. We can use our rules or our formula for angle measures inside of a circle. And that tells us that we know that the measure of angle 126 is going to be equal to 1/2 of the known arc 172 plus our unknown arc, which I'll just put as x. And we're going to fraction bust here. Let's multiply both sides by 2. And that means 126 times 2 is 252 is equal to the 1/2 that's multiplying both sides by 2 is going to get rid of our 1/2. And then we're going to be left with 172 plus x. Subtract 172 from both sides and you're going to get 80 equals x. Remember, that's not our answer. Our answer is the measure of arc BC is equal to 80 degrees. There is our answer. So I'm going to go ahead and fill that out. This is 80 degrees. Alright, next question. What is the measure of angle AEB? Well, this angle right here, class, is supplementary to 126. Together they make a 180 degree angle, or a straight line. And that means to find this answer, I'm just going to take 180 and I'm going to subtract 126 and I'm going to get 54 degrees, and I'll label that 54 degrees. Okay, last question. What is the measure of arc DC? So this arc right here. Now we can't use semicircles because I don't know if chord DB is a diameter or not. I don't know whether chord AC is a diameter or not. In fact, I know it's not, because look, 80 plus 66 is 146, not 180. So that can't be a diameter. I'm going to have to use my same property, or do I? I could go 54 equals 1/2 of 66 plus x, or I could also notice that, hey, I've got all the arc measures of every other piece of the circle. The only one I don't have is DC. Let's use that. That's a little bit faster. Not much. So I know the whole circle is 360. I'm going to subtract 172. I'm going to subtract 66. And I'm going to subtract 80. And if I put that in my calculator, I will get 40 degrees. And that means I know the measure of arc DC is 40 degrees. If I put this in my calculator, let's take a look. 66 plus 40 is 106. 106 divided by 2 is not 54. Oh, I see my issue. That's good I checked my work. Let's put that in the calculator again. I haven't done it yet. 360 minus 172 minus 66 minus 80 is equal to, oh, there's our problem. Our answer is actually 42 degrees. And good thing I checked my answer. So that's actually 42 degrees. I'm going to correct it on my diagram. And now let's take a look. 66 plus 42 is 108. Half of 108 is 54. That makes total sense now. So our answer comes out correct. All right, question number 58. The radius of circle R is 5 feet. Segment RT is 13 feet. Segment ST is 12 feet. Is line TS tangent to circle R? Prove whether it is or is not. Write your final answer and proof as a complete sentence. Well, we know, class, that if line ST is tangent to circle R, then it better make a right angle right here. This has to be a right angle. So this angle right here has to be a right angle. If it is, then we know that line TS is tangent, because a tangent and a radius, which touch at this point right here, will make a right angle. If it's not a right angle, then we know that line ST is not tangent. So let's use Pythagorean theorem. The radius is 5 feet. And now I know we're tempted to label this section as 5 feet as well, but they told us the whole length of RT. The whole length of RT is 13, so I know the hypotenuse, or the supposed hypotenuse of this triangle, and ST is 12. So we're going to use Pythagorean theorem. A squared plus b squared. Let's see if it does equal c squared. So 5 squared plus 12 squared equals 13 squared. If that's supposed to be my right angle, then this must be my hypotenuse. This is 25 plus 144 equals 169. Let's combine like terms. Oh, and look, we ended up with a Pythagorean theorem that came out true. Since the Pythagorean theorem is true, then we know line TS is tangent. So our answer should be line, oops, let's change that color so you can tell the difference between that and my work. Line TS is tangent to circle R. There's my conclusion, and here's my evidence. Because angle RST is a right angle. So there is our evidence to support it, and of course our calculations are up here to prove that to be true. So we know that line TS is tangent to circle R because we know that RST is a right angle, and that is the rules of radiuses that touch tangent lines. Alright, let's take a look at our last question in this video. The minute hand of this clock is 7 inches long. How far will the end of the minute hand travel? That means we're going around the circle, that is circumference. So if we're going to figure out how far it traveled, it's going to be an arc length, we're going to have to know what the circumference of this circle is. Let's find it. The circumference is going to be 2 pi r, which is 2 pi, the radius is 7 because the length of this minute hand is 7, 2 pi 7. So the circumference is 14, oh, not 14 inches. How about 14 pi inches? And now we want to know how far we're going to travel. Well, that's just an arc length. So we're going to take the total circumference and we're going to multiply it times the fraction of how much of the circle we want. Well, we know that a whole clock is 60 minutes. And we want to travel 5 of those minutes. Notice I'm not using degrees anymore. You could use degrees. You could figure out how many degrees 5 minutes is over a total of 360 degrees. It's a lot of work. We'll just go 5 minutes out of 60 minutes, and we put that in our calculator. We're going to get approximately 3.7 inches. And then question 60, how about if we travel 25 minutes? Well, that's no big deal. We've done the hard work already, finding the circumference. 4 pi, we're going to travel 25 minutes out of a total of 60 minutes. And that's going to be approximately 44.4 inches. Let's check that in our calculator real quick. 14 pi times parenthesis 25 divided by 60, close parenthesis, 18.3. Oh, that's not correct. What did I do wrong? Let's try it one more time. 14 times pi times 25 divided by 60 equals 18.32. Oh, I have a mistake here. It's not 44.4. It is 18.3. So let's correct that. This should be 18.3. And that makes sense because moving 5 minutes, we're going to move 5 minutes 5 times. So 5 times 3.7 is about 18. So 18.3 makes sense. Good thing I checked my work again.